We'll now discuss how to find the area in a region between two curves. So the idea is if I have this graph with these two functions and I want to find the area in the middle. Well, taking the integral of the top function gives me the area underneath that top function. And if I take the integral of the bottom function, I get this area underneath the bottom function. So if I want just the area in the middle, I can integrate from a to b of f of x minus g of x dx. The idea is the f of x gives me the entire area under the top curve, and then the g subtracts out the extra stuff we don't need. And the important thing is that f of x needs to be greater than or equal to g of x. It does need to actually be the top function whenever you have a picture. Our first example, we're going to look at y equal to x plus 1 and y equal to x squared minus 1. If we think about the graph of this, x plus 1 looks something like this one, and x squared minus 1 looks like this. The first step is to find our intersection points so we know how our bounds to find this area in between them. And to do that, we just set them equal to each other and solve. I can get everything on one side. That would give me x squared minus x minus 2, and then I can factor into x minus 2x plus 1. So we get 2 and negative 1. So these are my limits of integration. I can see that x plus 1 is on top. So I have x plus 1 minus my bottom function, x squared minus 1. And make sure when you subtract, you do distribute the negative sign here. So now I have x minus x squared plus 2 dx. Once I integrate, this becomes 1/2 x squared minus 1/3 x cubed plus 2x, going between negative 1 and 2. So if I stick in my upper bound, 2 squared is 4 times 1/2 is 2. 2 cubed is 8 times 1/3 is 8 over 3, and then 2 times 2 is 4. When I subtract out my lower bound, negative 1 squared is 1 times 1/2 is 1/2. Negative 1 cubed is negative 1 times negative 1/3 is plus 1/3, and then negative 1 times 2 is negative 2. And once we work this out, we get that the area is 9 over 2. Our next example, y equal to the square root of x and y equal to x squared. If we think about this graph, here's y equal to the square root of x and y equal to x squared. And you can set them equal and solve, but we can see that our bounds are going to be 0 and 1, since the square root of 0 is 0 and 0 squared is 0, and then the same thing holds for 1. The square root function is on the top. We're going to rewrite this as x to the 1/2 minus x squared. So if I add 1 to the exponent, I get 3 over 2. Divide by that number is 2/3. X to the 3 over 2 minus 1/3 x cubed, going between 0 and 1. When I stick in 1, I end up with 2/3 minus 1/3. Sticking in 0 just gives me 0. So the area between here is 1/3. Next, 1 plus x squared and 3 plus x. If I look at the graph of this, here's 3 plus x, and then 1 plus x squared. To find my intersection points, I can set them equal. Getting everything on one side to factor gives me x squared minus x minus 2, which is x minus 2x plus 1. So my intersection points are 2 and negative 1. The 3 plus x is on the top, minus the 1 plus x squared on the denominator. Or on the bottom, not the denominator. So this gives us, once we distribute the negative sign, the integral from negative 1 to 2 of 2 plus x minus x squared dx. And while this is written in a slightly different order, this is the same integral as the first problem that we did. So we can say that this is 9 over 2. Our next example, we're going to look at sine of x and cosine of x between x equal to 0 and their first intersection points. So we have our first function, and then the second function looks like this. So we want this area here. So first we need to know this intersection point. And this just requires knowing a little bit about the unit circle and knowing that they're equal at pi over 4. So this is the integral from 0 to pi over 4. Cosine is on top. So we have the integral of cosine x minus sine x dx. The integral of cosine is sine, and the integral of sine is negative cosine. So this will be plus cosine, going between 0 and pi over 4. Evaluating, sine of pi over 4 is the square root of 2 over 2, and cosine of pi over 4 is the square root of 2 over 2. Sine of 0 is 0, and cosine of 0 is 1. So once we work this out, we get the square root of 2 minus 1. Our last example will be a little trickier. We want to look at y equal to 2x squared plus 10 and y equal to 4x plus 16, specifically between negative 2 and 5. So if I think about the graph of this, it looks something like this. However, negative 2 and 5 are not our intersection points. They're around here. So we have to really think about this. First, we actually do need to know these intersection points. So we'll set these equal and then try to solve. Getting everything to one side gives me 2x squared minus 4x minus 6. And then once we factor, we have 2 times x minus 3, x plus 1. So our actual intersection points are 3 and negative 1. So if we look at this first section here, from negative 2 to negative 1, we can see that our function 2x squared plus 10 is on the top. And then we need to subtract out 4x plus 16. Between negative 1 and 3, we have 4x plus 16 on the top. And then we'll subtract out the 2x squared plus 10 dx. And then finally, between 3 and 5, we're going back to the 2x squared function on top. And then we subtract the 4x plus 16. So we did have to do this one in pieces. So now let's try to integrate this. So once we simplified that, distributed all the negative signs, we had the integral from negative 2 to negative 1 of 2x squared minus 4x minus 6 dx, plus the integral from negative 1 to 3 of 4x minus 2x squared plus 6 dx, and then plus the integral from 3 to 5 of 2x squared minus 4x minus 6. So once we integrate this, we get 2/3 x cubed minus 2x squared minus 6x between negative 2 and negative 1, We then have plus 2x squared minus 2/3 x cubed plus 6x going between -1 and 3. And then our last part says 2/3 x cubed minus 2x squared minus 6x between 3 and 5. So if we try to work this out, -1 x cubed, or -1 cubed is -1 times 2/3 would be -2/3. It would then be -2 plus 6. We would then need to subtract. -2 cubed is -8 times 2/3 is -16 over 3. We would then have -8 plus 12. For the next part, evaluating at 3, 9 times 2 is 18 minus another 18 plus 18. Evaluating at -1 would then give me a 2 plus 2/3 minus 6. And then evaluating at 5. 5 cubed is 125 times 2 would be 250 over 3 minus 5 squared is 25 times 2 is 50 minus 30 plus, or minus rather, evaluating at 3, which gave us 18 minus 18 minus 18. And then this finally gives us 142 over 3.